take our temperature, can give us the reading of the temperature of our body without any contact, and also recognize the face of the person, and as well as uh, it can also save the face of the person with his date, name, and temperature of the person in a database, so that we can monitor their health. And so such a system is very helpful for the for entry in airport, or in a railway station, or in the office, uh, in the time of COVID-19, because as we know, we need to do the thermal screening. We have to go through the thermal screening, and if the temperature detected normal, then we are only allowed to enter in the certain area. So what this system do actually, it reads the temperature of the body, of your body, without any physical contact with the temperature sensor. And it also have a camera that takes your picture and recognize your face, and and then compare the temperature whether you have a fever or not. If you have a fever, then it will stop you and save the person's face and face image and the temperature in its database, and not allow the person to go in the certain area. And if the person detected as a normal temperature, and so he also, so the device save the peak of the person with his with the level of temperature and time of his entry to the area, and uh, that device let them go that he is okay, have normal temperature, and there is no symptoms of COVID-19, so he can enter the area. So such a system can be very helpful uh, for entry or boarding in the airport, or for entry in the railway station, or in any auditorium, uh, where it check the temperature of the person, so that it can detect the symptom of COVID-19, and also it will recognize the face of the person. So let's talk about what are the things that we need to make this project. What are the things that we need to make the device, and how we can make a device in very low cost. So we will go through the various LCD displays, and we will select right display for our project, and right camera and right sensor for the project. So as you can see here in the picture, I have made the device, and attached the camera like this, and made a device and enclosed the whole device in a box like this, and put it on the door. So anybody want to enter, so you have to just come in front of the camera. It will measure temperature of the person, and tell him that your temperature is very high and you have a fever, or your temperature is normal and you can now go. So in this way, this device is very helpful for automatic thermal screening, as it is very hard to do the thermal screening of every person, measuring the temperature of every person by hand, and it became very complicated and tiredful job for the staff, for the medical staffs, to do the thermal screening of each person one by one. So this device do all everything automatically. It saves the data, recognize the face, and measures the temperature as well. So for this, we need a sensor, certain sensor that can measure the temperature without any contact. So here we have a contactless sensor named MLS90614. Actually, this sensor reads your body data uh, without the physical contact with the sensor, and under the certain distance of 5 to 6 centimeter, it can read the body temperature and tell you whether you have a high fever, or you have normal body temperature. So this device can read your temperature of your body from the distance of 5 to 6 centimeter, and it works on the voltage level of 4 to 5 uh, volt, and it has a I2C interface, so you can connect the with the Raspberry uh, Pi on I2C interface. And now let's select the right display for our project. So here are the various display options for your DSI display and HDMI display. So here is the RCA display that can be that is generally used in the car back camera as so you can use the display as a Raspberry Pi also have a RCA connecting cable. It give you the video output in RCA format as well, and you can also use the DSI display directly. Connect the Raspberry Pi DSI port to this display to the Raspberry Pi DSI port, and then use it, or you can use the HDMI display for this purpose. So here I have used the HDMI display uh, connected with the Raspberry Pi. So here are the various display options that we can choose for the Raspberry Pi. So if you want to go for the cheaper cost, low cost, so so you can choose the RCA display, but you don't get the touch screen option. So we are not using the touch screen option. So you can use this display in your Raspberry Pi, connecting with your Raspberry Pi, because this you can get the display of with the cost around 1000 to 1500, and this DSI display is little bit of a high cost, cost ranging between the 5000 to 8000, and this HDMI display you can get display from 3000 to 10,000 rupees in between, depending on the features, resolution, and the size of a display. So I have used this HDMI display as connected with the Raspberry Pi to show the face of the person, recognizing its temperature and another data on the display, and also save the data of the person in the background. So here you can select any of the display, connect your Raspberry Pi with this display, and then you have to connect the sensor with the Raspberry Pi to the I2C pin of the Raspberry Pi. That is SCL HDL pin with the Raspberry Pi. You have to connect the B in pin to the Raspberry Pi 5 volt pin, and ground pin to the Raspberry Pi ground pin, and then SCL to the Raspberry Pi SCL pin, and SDA to the Raspberry Pi SDA pin. So after connecting the sensor and connecting the display with the Raspberry Pi, you have to now you can now start the coding with the Raspberry Pi. So before we go for the code, we have to install some libraries that we need in our project. So for to do so, you have to go. So let me connect my Raspberry Pi with the PC. Here I am using the BNC server to connect with my Raspberry Pi. Let me check it can to our network or not. Wait for a minute. I'm connecting with my Raspberry Pi right now. So it is booting right now. Yeah, now our Raspberry Pi is ready to connect. So if you want to control your Raspberry Pi remotely, you can install the BNC server to a Raspberry Pi and then connect your desktop with the Raspberry Pi, having both the desktop and Raspberry Pi connected on the same Wi-Fi network. So as I have connected my Raspberry Pi, so here is my Raspberry Pi desktop, and you have to go to the Linux terminal either by clicking here, or you can get the Linux terminal on uh, in in accessories and the terminal. So you can go here and go to the Linux terminal. Now you can install the certain libraries and that we require here in our project. So to install the library, you have to type sudo pip3 install and then the library name. Here we are going to use these libraries. Let me tell you and explore the library ESP. Here I'm using the ESP because with the use of this ESP we will announce the temperature of the person and whether he is fit for entry in that area or not. Suppose that if the temperature of the person is detected as more than 36, 37, or more than 38, so it detects that person having fever. So the ESP, using ESP, we will announce that you have a fever and you are not allowed in the area to enter in the area. So using ESP we will do that. And here we have used the MLS 906614 sensor for getting the temperature of the person without any contact. So what you have to do is to put your camera of the Raspberry Pi, and then the sensor or that sensor attached with the Raspberry Pi like this on the box, so that when you came in front of the camera, your face will come in the camera, and also the sensor will detect your temperature. After that, we will use the OpenCV and face recognition library. The face recognition library will recognize the face of the person that who are allowed to enter the area, and then OpenCV is to process the image and then show it back on the screen like this. So after installing the library, you have to just type sudo pip3 install esp and it will install the esp library. Then same with OpenCV OpenCV, and same with the face recognition and another library. So after installation of library, you can now go to the Python IDLE. You can open the Python IDLE from here, and then start the coding. Here I have already done the coding part. So here is my code for this project. So here we have to import the libraries required in our project. So I'm using the face recognition library for the recognizing the face of the person and CV to process the image. And then this time date and time library I am using so that we can get a time stamp of on the image of the person. Like suppose that I am trying to enter at 5 o'clock on 26th of August to the particular area. So when I go to the in front of that device, so that device will automatically capture my image and temperature and label with them with the time and date, and save in its database, so that later we can access that this person has tried to enter this area having the temperature this, and this is the place of the person. So to save the database with date and time stamp, here I am using the date and time library and importing it in the code. Next, we have to set the MLX90614 sensor here. Here is the address of MLX90614 sensor, I2C address. So after that, you have to name the image of the person who are allowed. Suppose that you are working on in the office and want to set the device there, so you can simply set up the device there, and here in the code you have to take the image of each person and paste in a folder, and name those employees image in this code. Suppose that I am working and my name is Ashwini, so I save my image in the folder that I am the employee, and I can take entry in that area, so that it can recognize my face and give me the entry as per requirement, and after checking my temperature. So after setting all those image name, we have created the arrays for the encodings and the face names respectively of the person who are allowed in the area. And if we haven't set that, then person image is recognized as an unknown person, and it still give the temperature of the person. So after that, us- using this piece of code, we will get the sensor data ambient. First we get the ambient temperature, so temperature of the environment. Then it will check that the object temperature, body temperature of us, and then it will show those both temperature on the Python cell. And also, next we will have to announce the temperature using the ESP. So ESP take the string format. So to announce the temperature of the person, we have to convert it into the string. So here we have created a variable temperature and convert it into the string format, so that ESP can announce the temperature of the person. So after getting the recognize the face of the person, we have the using this piece of code. It will take the temperature of the person and announce, hello, your name is this and your body temperature is this. If the body temperature is greater than the 37, means he have a fever. So we have created a if condition. So if the person is have a body temperature greater than 37, so he is not allowed. And if that person is below the 37, so he have no fever and he is allowed to enter the area. So using a we will announce that you are ready to enter in the area, or you are not. If fever is detected, you are not allowed to enter in the area using this piece of the code. So after that, we have to save the database of the person, whether he is going to enter, and this person has came in front of the camera for the entry. To do so, we have used this piece of code so that it will actually create a file, a text file that labels the name of the person, what is the name of the person, then temperature of the person, and with the date and time stamp, and also it will save the image of the person in a directory. So we have to set a, a path where this code will save the image of the detected person and image of the detected person and also the temperature of the person. So here I have saved this path on this path directory. It will save the image. It will save the image of person who came in front of camera and of which you have taken the readings. So in this way, the whole process get automated. The person, this device can recognize the person face, and then it get the temperature of the person and asks him whether he is allowed to go uh, uh, and announce that whether he is allowed to go in the area or not. Whether he have high temperature, he is not allowed. If he have low temperature, he can go in the area. So this way, it takes all the everything everything automatically and also save the database of the person. So when you run this code, you get interface like this. I am giving you showing the demo video. So here it is recognizing my face, and here it is showing the name of showing my name and the temperature of me, and it is also showing the temperature of me. So what if the temperature is below the threshold temperature, like below the 37 degree that I have normal temperature, it will show the name in green and also temperature in green, and also announce with the that your face is polarized as Ashwini Kumar Sinha. Now you are allowed to go in the area because you have a low temperature, no fever detected. So it is also I have also tested my face with a higher temperature by putting some water thing near the sensor. So when it detects the high temperature, it turns the whole thing into the red that you are not allowed, and your temperature is greater than 36 degree and you have a fever and you are not allowed. So you can see the thing get red when the temperature is detected more than 36 degrees. So in this way it will work, and this whole thing done in the real time. Now now let's check how we can where we can see the database of the uh, saved database. So here you have a text entry.txt. So when any person came in front of the camera, it will save the temperature of the person and the name in this file that Ashwini Kumar Sinha has came in front of camera at this date and time having the temperature this. So this in this way it save the entry of every person with date and time stamp and temperature stamp in a text format, and it will also save the person image as suppose that it had detect the normal temperature, then it have it save the person's face image in normal temperature folder, and with high temperature person it will save the person image in high temperature folder like here. So you can get the peak of the person saved in different folder having high fever and who have normal fever, and also the name of the person in the text format. So you get all the database so that you can track the daily health of the person. Like suppose that an employee came daily to the office and he go through the temperature screening daily, and so you can monitor the daily health data whether his temperature is increasing, decreasing, or for the further study or on his body temperature and another thing. So in this way we can make a simple device that can do everything: temperature screening and face recognizing thing automated. Any question answer? You can get this whole project on EFI Electronics for You website. You can search this project. You will get the whole source code and procedure of making this project, and you will get better understanding in the article. Price, so normal price of the MLX 904 614 sensor is 1500, but in the COVID-19 time the price of the sensor has increased to the 2000 rupees, but in but the actual price of the sensor is 1500. Yeah, it's a contactless temperature sensor. The sensor name is MLX90614 sensor. What is the maximum range? Maximum range is I have tested that it will work fine with the distance of 6 to 7 centimeter, and its temperature range. So here you can see in the PPT the temperature sensing range or sensing range of the sensor, and its accuracy is 0.5 degrees centigrade. So here you can see the details of the temperature sensor, its working voltage range, the temperature range, and accuracy and other things. Okay, thank you everyone. I think we have to wrap it up here.